Professor Howell could not be with you today, so he asked if I would try and tell you the history of the complex numbers. As you see, I borrowed the telephone Buddha from the Dr. G. And I tried it 3 times from the 16th century. I have a bit of a problem though. The telephone with the door, also called the TARDIS board, is 2. But there's an emergency button on the other side of the door. If I can pound a hole in the wall with this board, then I can reach through, press the button, the door will open and let me out. 1 moment, please. Well, it is a bit of a stubborn door, but I think this next one will do it. Okay, now I reach through and I try a little lower. Yes, there it is. I press it.
That was easy.
Okay. Now these doors open, and I can come and talk to you about this marvelous history of the complex numbers, which goes back to the solution of the cubic equation, something that I am responsible for. In order to show it to you, all I have to do is come into the
Classroom, hello. I must wear this class.
Bring the pain.
Well, Professor Howell, he asked, can I please tell you the history of the complex numbers? A very exciting history, because I am part of it, and the book I published that I'm going to talk to you about is responsible for it. So let's get right to it. This is going to be the story of the imaginary numbers and why they are not imaginary. Okay, so let's keep track of some dates, just to see how the history developed. You may not have heard of this mathematician, Luca Pacioli. Can you say that?
Luca Pacioli.
He was the mathematics teacher of Leonardo da Vinci. Now, he published a book So this is the timeline. We're going to start back almost towards the end of the 15th century. He tried to solve the equation of the general cubic. Now, Professor Howell told me when you were in high school, you all know the general solution of the quadratic, yes? What is the solution?
Plus or minus the square root of b squared minus 4 times g root of a.
I'm almost sure you sing the song that you heard. Now, why is there no a in front of the x cubed? Right here. You don't need an a. Why do you not need the a? Because if you solve this for 0, what can you do? Just divide both sides of the equation by a. And then the leading coefficient by the x cubed, or the x squared in this case, equals. So if you can solve this, you can solve it. So this is what he looked to do. But what does he say? Impossible. I do not have a proof for it, but I try and try and try, and I cannot solve it. So I say, yeah. Okay, well, mathematicians, they love a challenge. The next person, Scipione del Ferro, taught at University of Bologna, where I am also a professor of medicine. He solved the depressed cubic. Why do you think this is called the depressed cubic? It has nothing to do with emotions.
No x squared.
No x squared term. Without the x squared term, we call it the depressed cubic. He figured out the solution to the depressed cubic. Here it is. Wow. Fantastic. the cube root of a bunch of stuff with a square root inside the cube root. And the two terms are very similar with a plus sign and a minus sign. There's the solution. Fantastic. Now you would think when he published this, what he would publish and tell the world. But he keep it a closely guarded secret. The question I want to ask you is why? Why did he keep this result a closely guarded secret?
Don't touch that.
Who are you?
Who am I?
Yes, you interrupted my class.
Who are you? I am, of course, the great mathematician, Antonio Fiore.
Antonio Fiore.
And I have come here to calculate my mathematical superiority over such a cockroach as yourself.
Everybody knows that your algebraic skills are at the level of an amoeba. So,
Everybody know.
how could you possibly outdo me in that?
Amoebas that don't do the math. I have come to create a problem out of my own brain cells to show my superiority over you. You will not be able to solve this problem.
Well, that's you. I do not believe this. Let's go to you, Chuck.
May I use the chalkboard?
Sure.
Okay. You have 5 apples.
You have 5 apples.
You take 2 apples.
You take 2 apples.
How many apples you got?
He is a total nitwit. This is a difficult problem. The whole world knows that if you have 5 apples and you take 2 apples, you have 3 apples.
I laugh at you. Everybody knows. If you take 2 apples, then you have 2 apples. Because if you took 2 apples, forget about it.
See, he's a total nitwit. The only way he can win a puzzle contest with me is with the trickery.
Thank you for not touching.
Okay. You think that you are so smart?
Oh, I know.
Answer me this.
Okay.
Suppose you have 4 teacups
Jeez.
and you take away 2 cups.
Jeez.
How many cups do you have left?
You see this guy? You see what I'm talking about here? I'm trying to do some math here. He's trying to use my problem against me because he's a nitwit. It's not going to work because either way, if you have or you take, it's both 2 cups. So the answer is 2 cups. Grazie. Grazie.
You are wrong. The answer is 38 cups.
What are you talking about?
Everybody knows. If you have 4 teacups,
Oh, come on.
you have 38 cups left. You say you are a total nitwit.
The only thing you can add right now is to my headache.
Your mother thinks that polygons are baby frogs.
You have a point. She's not a bright woman, but let's not talk about my mother.
Gentlemen, you know that these trading of these insults will not settle anything. Do you have challenge problems prepared for each other?
Oh, yes. And he will not be able to do this one. I promise.
Here are my challenge problems to you.
To you!
Okay.
It's
Good. Then
light,
we will have you
easy.
both return to present your results during chapel on Monday, January 31st.
Okay.
May the better mathematician win.
Oh, I will, thank you very much.
Something like 8 days from now, okay?
Pay attention in class. What are you doing?
You only have a 3-digit IQ because of the adjustment.
2 wrongs don't make a right.
You should know nothing about foods.